Hello everyone. In this video, we will continue talking about the secant method. We will talk about how to implement the secant method in MATLAB. Let's see this example. Consider the function fx, which is equal to x squared minus 2. And we start with the initial guess x0, which is equal to 0, and x1, which is equal to 1. Assume that the two epsilon constants, epsilon step and epsilon abs, are both equal to 1e negative 5, and we assume that the maximum number of iterations we want to do is 100. And the first question asks you to write all the codes in the main file, and the second question asks you to write codes in the main file and a separate function file, which is called secant.m. You can use either for loop or while loop for the iteration process. Let's see the first question. Write all the codes in the main file, and we can create a new script. So let's clear all, close all, and if you want to see more digits, you can format long. And the function, because we need to write all the codes in the main file, so we should now create a separate function file. So we can define the function in the main file by using the @ symbol. So it's x squared minus 2, and the initial guess x0, which is 0, and x1, which is 1. The maximum number of iterations is 100, and the two epsilon constants, which is epsilon step equal to 1e negative 5, and epsilon abs, which is also 1e negative 5. And then we can use a for loop to for the iteration process. Assume I equal to 1 to n, and then we can use the formula to update the approximation of the root. So based on x0 and x1, we can get x2, which is equal to, according to the formula, which is x1 minus fx1 times x0 minus x1 over fx0 minus fx1. Okay, so this is the formula to update the approximation of the root based on the previous two approximations. And then there are three different halting conditions. The first one is that the process will converge. So if both condition A and condition B are satisfied, so let's write here. So we have, for the first halting condition, we have the halting condition is satisfied when both condition A and condition B are satisfied. And condition A is that the absolute value, so the absolute value of xn minus xn minus 1, it's actually xn plus 1 minus xn is less than epsilon step, and condition B is the absolute value of fxn plus 1 is less than epsilon abs. So this is the first halting condition, and we can write this here. If abs x2 minus x1 is less than epsilon step, and the absolute value of fx2 is less than epsilon abs, So if the first halting condition is satisfied, then we find the root, right? So the root will be x2, and then we can stop the iteration process by using break. So the second halting condition is that there is a division by zero problem, which means fx0 is exactly equal to fx1. If that happens, we need to terminate the iteration process. However, this scenario can be included in the third scenario. So the third scenario is that when the maximum number of iteration is reached, then we need to stop the iteration process. So when you have a division by zero problem, the process will not converge, so it can be included in the third scenario. So else if I equal to n, we can have an error message shows that the Secant method does not converge, and we can end this if condition. So when we use a formula to update the approximation of the root based on x1 and x0, we get x2, and in the when we start the next iteration, we need to update x0 by assign the value of x1 to the variable x0, and then assign the value of x2 to the variable x1. All right, then we can end this for loop. So this will be the code for question 1. So let's see if it runs well. Let's save this as main.m, and then so let me see. Line 16, if abs less than epsilon step, and so here should be a bracket, then let's run again. So the root is very close to the square root of 2. Okay, so this is question 1. So question 2 is write some of the codes in the main file, and then it calls a function file secant.m. So we can move this part to a function file. So this for loop, we can create a separate function file which is called secant.m. So the first line should be function root equal to secant, and the input parameter is f, x0, x1, maximum number of iteration n, and epsilon step, and epsilon abs. Alright, so this will be the function file. Then we can save it as secant.m. Okay, so in the main file, we can call this function file to guide the root. So assume root is r, then we call this secant f x0, x1 in epsilon step and epsilon abs. Right, so we can call it. So the r is equal to the root. All right, so this is question 2, and let's see how to write the function file by using while loop. So right now we are using for loop, so we can change this to the while loop. So when you use while loop, you need to write a condition for the while loop, and this condition is the opposite of the halting condition. So let me show you here. So you have A and B as the first halting condition. So when you want to change this to the condition to continue the process, so this is the halt condition. So the opposite of this halting condition will be A opposite or the B opposite. If this is satisfied, then we continue the iteration process. It's this condition that we need to put in the while loop. So A opposite will be the absolute value of xn plus 1 minus xn larger than or equal to epsilon step. And the B opposite will be the absolute value of xn plus 1 larger than or equal to epsilon abs. Okay, and let's put this condition to the while loop. So it should be abs x2 minus x1 larger than or equal to epsilon step, or the absolute value of fx2 larger than or equal to epsilon abs. Okay, if this is satisfied, then we continue the iteration process. So we update the approximation of the root based on the previous two initial guesses. And then since it's while loop, so we need a counter. For example, it's C initially is 0, and after each iteration, C equal to C plus 1, right? Then we can judge if C reaches the maximum. So if C is equal to N, then we can display that this method does not converge, and then we can break, or you can use error, send the user an error message. It's the same thing. Okay, so then the same thing, we need to update the variable x0 and x1 by assigning them the new value x1 and x2 respectively. Okay, in the end, we need to return the root. So the root will be equal to x2, the most updated approximation of the root. So this will be the secant function by using while loop. So let me save this and then run to see if it works. Oops. See the error in line 4. Okay, so we used x2, so we get x0 and x1 from the user. However, in the while loop, the condition of the while loop, we used x2, which is not initialized. So we need to initialize x2. So a good way to initialize x2 is to based on x0 and x1 to get using this formula to get x2. Okay, so this will be the x2. If x2 satisfies the while loop, satisfies the halting condition, then we will not go into this while loop, which is fine, because then here we can return the root as x2. Okay, if x2 doesn't satisfy the halting condition, we will go into the while loop and we will update x2 in each iteration, and then in the end, this new x2 will be assigned to the root. So this code will work. Let me show you. If we call this function, then we have r equal to the root. Okay. All right. So this is how to implement secant method in MATLAB. Also, I showed you how to write the iteration process by using either for loop or while loop. In next video, I will talk about the quiz problem for this class.